Hi! For this video, we're going to learn about organic reactions. Now, what are organic reactions? Simply defined, organic reactions are reactions that involve organic compounds. It can be synthesizing new organic compounds from existing organic compounds, or when we break down certain organic compounds to its component compounds. So there's so many types of organic reactions, and in this video, we're gonna learn the basic organic reactions that our basic organic compounds undergo. But let's recall first what are the basics in a chemical reaction. When we write chemical equations of chemical reactions, we remember that first we use a single reaction arrow. A single reaction arrow separates the starting material, which we call the reactants, and we place them to the left of the arrow, and the one to the right of the arrow where the arrowhead is going represent the formation of what we call the products. The reagent in which the chemical substance with which an organic compound reacts is sometimes drawn on the left side also of the equation with the other reactants. But other times you would see that this reagent or substances are drawn above the arrow itself. Now, although also the solvent is often omitted from the equation, most organic reactions take place actually in a liquid solvent. Sometimes it's represented or written, sometimes it doesn't. And then the solvent and temperature of the reaction may be added also above or below the arrow. I'm going to give you some examples in a while. And then you would see also symbols such as E or HV and delta sign. This is delta, the small triangle. Both of that indicate the use of or the requirement of light and heat for the reaction to proceed. E for energy, and the delta usually your heat, the supply of your heat. So E for energy, that means light. HV is actually an equation in physics that represents the amount of light that you supply in the reaction, and the delta represents the presence of heat. And again, those are requirements for some reactions to proceed. Now, what are some common examples? So, for example, you would see an equation that looks like this. So, you have your cyclohexene here. Plus means reacts with Br2, that's your reagent, one of the reactants that will react with your cyclohexene here. So Br2 is a diatomic molecule, that's why it's Br2. You put it on the left side with a plus that separates cyclohexene, or sometimes you can draw the cyclohexene alone on the left side and you put the reagent on top of the arrow. Either of this is correct. And you notice that when the cyclohexene reacts with Br2, your Br2 replaces the hydrogen and removes the double bond, which is the pi bond, and it makes the Br to be added to your cyclic structure. In this case, you get 1,2-dibromocyclohexane. So this is the transformation from an alkene to an alkane. And then with the addition of your two bromine elements. Other reaction parameters can also be indicated. So you have Br2 here. For the reaction from cyclohexane, you want to get a bromocyclohexane from that. So you would see the reagent placed on the top of the arrow, and the other parameters such as your light HV or delta heat with CCl4 as the solvent in the reaction. For the reaction to take place, it requires a liquid solvent. Then you may put all the factors, other parameters below the arrow. So when you see these parameters here, it means these are additional factors that are needed for the reaction to proceed. So again, HV represents your light and delta represents the heat, and the substance below it indicates the solvent where the reaction is taking place. So that's how it looks like. Another one is for sequential reactions. Some reactions don't proceed one way. There are some sequence of reactions, series of reactions in order for you to get your desired product. If there are more than one reaction way for the reaction to proceed. That means you get some intermediate, we call them intermediate compounds. These are the tentative compounds that will still further react so that you can get the product that you desire. So sometimes if you have like this, two sequential reactions, you begin with this reagent here, and then the moment you see number one here, so this is the first reagent that will react to your reactant on the left, and then the first reaction will be this other reactant, then the second will be placed below the arrow. So that's a series of reaction, and the final product of that is indicated or written on the right side of the arrow. Sometimes the byproducts, which are again waste products that are not actually considered as significant in the reaction, you just omit them and you don't indicate that, or you don't write them anymore in your chemical equation. Okay, so that's how it looks like if you have a complicated sequential reactions that is being underwent by your organic compound. Okay, so let's now take up the different types, the basic types of organic reactions. The first one is substitution reaction. Substitution reaction is a reaction in which an atom or a group of atoms is replaced by another atom or group of atoms. So substitute, you replace. So in general, for example, this Z will be replaced by Y. So Y will take over the place of Z and Z will be alone. Z can be a hydrogen or a heteroatom. Heteroatom means any atom other than carbon or hydrogen. Sometimes it's an element that's more electronegative than your carbon. So basically, it's just substituting. A common example of that is this one. You have CH3I and then you have chlorine as the other reagent. And so Cl, the chlorine ion, replaces your iodine, and iodine will be alone, and chlorine replaces iodine spot in the product side. So that's basically substitution. In another example, you have chlorine here being replaced by your hydroxide ion, OH replace Cl, and Cl will be alone on the right side of the arrow. So basically, the ions have to be compatible in order for them to be able to substitute successfully. Okay, so that's the first one, substitution. The second is elimination. Elimination is a reaction in which elements of the starting material are lost or eliminated or are thrown so that a pi bond is formed. So, for example, you have XY elements here. These are sigma bonds. Then react it with a certain reagent that will remove X and Y. So they'll be together and form another compound. And the missing bond here will become a pi bond. So this is how you form an alkene from an alkane. You just let it undergo an elimination reaction. So common example is here. You have H and Br being lost and eliminated by another reagent that contain your hydroxide. So when you have hydroxide here, that will be the reagent for this. This compound will now have a pi bond in the end, still retaining the four hydrogen. The OH and the H will bond together and become H2O, and the other bromine will be alone as an ion here, Br negative. So we eliminated HBr so that your two carbon compounds will have a pi bond. In the second example, you have a cyclohexane with two hydroxyl groups. And so you remove one hydroxyl and one hydrogen. You remove these two with the presence of your sulfuric acid, H2SO4. Then you get a double bond cyclohexene. And of course, OH and H together will become water. So that is elimination. All you need to do is just take note where the elements are going so you'll know what type of reaction that is. The of the reactions will just speak for itself. So that's the second one. Now, let me stop here. We have substitution and elimination. I want you to take note of these two reactions, and you watch out for the next series of this video in which we're going to tackle the other three basic organic reactions. So let me stop here and take note of all the things you've learned from this short lecture. Bye for now.